Good morning students. I hope you all are fine. In previous video we were discussing about the colligative properties. We have done two properties. Today we will keep continue and we will do property 3, that is depression in freezing point. First of all we should know about that what is freezing point. Students, freezing point is a temperature. Freezing point is the temperature at which solid state and liquid state vapor pressure of a substance becomes equal. Then the temperature is known as the freezing point. So we can say the vapor pressure, the temperature at which vapor pressure of solid and vapor pressure of liquid state of a substance becomes equal, that temperature is known as the freezing point of that substance. I will make understand to you with help of the diagram. So we will understand it with help of the graph. We will draw a graph vapor pressure versus temperature. Let us consider this is the graph for vapor pressure of the solid and this is the vapor pressure of liquid state of that substance. You know very well, vapor pressure of liquid is always greater as compared to vapor pressure of the solid. Okay, because they can produce more vapors. So student, when we decrease the temperature, then vapor pressure also decreases because vapor pressure is directly proportional to the temperature. Because we are going to freeze the solution, then when we decrease the temperature, then vapor pressure also decreases. And at this point, vapor pressure of solid state of that substance and vapor pressure of liquid state of that substance both becomes equal. So this is the temperature for this. So this is known as the freezing point of this. This is the freezing point of the pure liquid. If I add some solute into this, then it becomes solution, and vapor pressure of solution is always less than vapor pressure of the pure liquid. So consider it is the vapor pressure of the solution. Now again, when we decrease the temperature, then vapor pressure also decreases. And this one is the point. This one is the point where vapor pressure of the solid state of substance and vapor pressure of liquid state of the substance becomes equal. So again, this is the freezing point. This is the freezing point of the solution. And this one is the freezing point of the solvent. So you can see the student, you can see here freezing point get decreases, and because decrease in freezing point take place in case of the solution, then it is known as depression in freezing point and it is denoted by del TF. Students, here del TF is equal to TF naught minus TF. TF naught is freezing point of pure solvent and TF is freezing point of the solute. Freezing point of the solution. Okay. And Depression is freezing point is also directly proportional to the molal concentration. Here M is the molal concentration of the solution. Molal concentration of the solution means we take the concentration of a solution in form of molality. Why do we take in form of molality? Because molality do not depend on the temperature. And elevation in boiling point we have already discussed in previous class. It is also directly proportional to the molal elevation, molal concentration of the solution. Now del Tf is equal to, now put the constant of proportionality, and here we will take the constant of proportionality Kf, Kf into M. Here Kf, it is the constant of proportionality. It is also known as the constant of the freezing point and cryoscopic constant. Students, if we take here molal concentration unity, then depression in freezing point becomes equal to the cryoscopic constant Kf. So what do you mean by the Kf? Kf, cryoscopic constant, is defined as the depression in freezing point if molal concentration of a solution is unity. Okay, so what is the unit of Kf? From here we can calculate unit. From here delta Tf is equal to Kf into M. M is molality, and unit of, from here Kf is equal to del Tf by M. Unit of temperature is Kelvin, and unit of molality is mole per kg. So what will be the unit for cryoscopic constant? It will be Kelvin kilogram per mole. So student, it is the depression in freezing point. Here we can calculate molecular mass of solute. Because molality we have already discussed, in case of elevation in boiling point, molality is number of moles present in per kg of the solvent. So number of moles we can calculate given weight of solute by molecular weight of solute. And if volume is given in grams, so we can convert it into the kilogram. Okay, so 1000 by given weight of the solvent. Here this is the weight of the solvent, and this is the given weight of the solute. So from here we can calculate molecular mass of solute. Okay students, we will take MB this side, then KB into WB into 1000 by WA. Take del TF in opposite side, del TF. So by using this formula, we can calculate molecular mass of the solute. And student, this property also depend on the number of the solute particles only. It does not depend on the nature of the solute. So it is also a colligative property. So we have done 3 colligative properties. Now move to the next. Next colligative property is osmotic pressure. First of all, we should know that what is the semi-permeable membrane. First, we will discuss about some basic terms related to this topic, semi-permeable membrane. Students, semi-permeable membrane is that which allows solvent only to pass through it. Means which permit solvent particles only, which permit limited particles only to pass through it. Like our skin. Our skin is also a semi-permeable membrane because in summer a lot of sweat is come outside from our skin, but our blood is also a fluid, but it cannot come outside from our skin. Okay, so our skin also we have like semi-permeable membrane. Second term is osmosis. Osmosis. Students, what do you mean by the osmosis? Let us consider if we take a container and it is separated by semi-permeable membrane. In one compartment of this, we take pure water. And in other compartment of this, we take sea water. Student, here we take pure water, so it we have like solvent. And in sea water, you know very well, a number of salts are present there. So it we have like solution. So through this semi-permeable membrane, only solvent particles can pass through it. So student, due to some atmospheric pressure, here pure water pass through this semi-permeable membrane and it mixed with the sea water. Students, you know very well, 71% of earth consists of the water, but only 1% water is used for the drinking purpose. And again, this process is converting pure water into the salty water. So student, what will we do? We have to stop it. So we will apply some pressure in opposite direction. Here we will apply some pressure. For stopping this flow of the solvent. Okay. So, and this pressure is known as the osmotic pressure. Osmotic pressure. So what do you mean by the osmotic pressure? Osmotic pressure is that pressure which stop osmotic pressure is that pressure which stop osmosis, or we can say which stop flow of the solvent. Okay, so or we can say the applied pressure is known as the osmotic pressure. Osmotic pressure we can denote it by pi. Now we will see the mathematical expression for osmotic pressure. Osmotic pressure is denoted by pi. According to ideal gas equation, you know very well, ideal gas equation is PV is equal to nRT. Here P is the pressure, but we have osmotic pressure here, so we can take pi instead of P here. So pi V is equal to nRT and pi is equal to n by V RT. Here n by V, number of moles per unit volume, is known as the concentration. So n by V is equal to C, concentration. So I can write in this way, pi is equal to CRT. So this is the expression for osmotic pressure. Student, from here we can calculate mass of the solute also. Here n is number of the moles of solute. So pi is equal to n by V RT. How can we calculate number of moles? Given weight of the solute divided by molecular weight of the solute. Okay, I can take V that side. Okay, RT. Now, if I want to calculate molecular mass of the solute, then take MB that side. MB is equal to WB RT by take pi V in opposite side. So this is the formula for calculating the molecular mass of the solute. Again we can calculate mass of the solute here. So this property also depends only on the number of the solute particles and do not depend on nature of the solute. So it is also a colligative property. Colligative property. And students, we can also purify this sea water. How can we purify? If this pressure is increased, again, if this pressure is more than the osmotic pressure, okay, then what will happen here? The water will start to pass, will start to move from solution to the solvent. And this is known as the reverse osmosis. Reverse osmosis. RO you use at your home for purifying the water, that is the RO. It based on the reverse osmosis process. Okay, so this is all about the osmotic pressure. And student, we have done all colligative properties here. I hope it is clear to you. So thank you. Have a nice day.